Hi everyone, welcome back to my YouTube channel. This side Abhinav, you are watching RKMATH-ODS. Today in this video we will further discuss another chapter of arithmetic quants, bot and stream. Before going too deep in this chapter, we will have to know that certain definition and basic points related to this chapter. The basic points are, first we have to know the first definition, downstream. What is downstream? The definition of downstream is that when the bot is along the stream, that is, bot is moving along the flow of stream. Second is upstream. When the bot is moving against the flow of stream. We will also call stream as water or river, etc. Firstly, let B be the speed of boat in still water. And what is meant by still water is that still water means that the speed of water or river flowing is 0. Another one is W. Be the speed of water or river flowing. Now the first question arises in our mind that how to define downstream mathematically. So mathematically suppose that this is river flowing with speed W. Let a boat is moving with speed B along the river. So we define the downstream speed is boat speed plus water flowing speed, that is B plus W, kilometer per hour or meter per second. In the same way, the upstream speed is when the boat is moving against the water flowing. So in this case, the speed of upstream is B minus W, kilometer per hour or meter per second. Now let X be the speed of downstream. As B plus W, as we above see that. Now let Y be the speed of upstream, which is equal to B minus W. Now X is B plus W and Y is B minus W. So how to find that speed of boat when the speed of upstream and speed of downstream and speed of upstream is given? So add add 1 and equation 2, we get that x plus y is equal to twice of speed of boat, which gives that speed of boat in still water is x plus y divided by 2, where x is speed of downstream and y is speed of upstream. In similar way, when we subtract equation 1 minus equation 2, we get that x minus y is equal to twice of w, which gives that speed of still water is x minus y divided by 2, where x is speed of downstream and y is speed of upstream. Now we have all got this basic points of this chapter, boat and stream. Now let's move to some questions. First type of question asked from this chapter is speed of boat in still water is 5 km per hour and the speed of stream is 3 km per hour. If the boat go from one point to another and come back to the same point in 5 hours, find the distance between points. Let's take boat moves from point A to point B. Now we are given that speed of boat in still water, which means B is given equal to 5 km per hour, and speed of stream is, which means W, is given as 3 km per hour. 3 km per hour. If boat grow from one point to another and come back same point in 5 hours, suppose that boat is moving from A to B in T1 time. So T1 is equal to distance AB divided by speed of, let speed of river flowing is from A to B. So speed of downstream is given by distance AB divided by 5 plus 3 B plus W. T1 is AB distance divided by 8. Now T2 from B to A. AB distance divided by upstream, which is equal to 2. So T2 equal to AB divided by 2, 5 minus 3. Now we are given that the total time taken from A to B and B to A is 5. So T1 plus T2 is given that 5 hours. So put the 1 and 2 in equation number 3. T1 is given that AB divided by 8 plus T2 is given that AB divided by 2 is equal to 5 hours. Now solve the equation. We get that AB multiplied by 10 divided by 16 is equal to 5 hours. From where we get AB is equal to 5 hours multiplied by 16 divided by 10. So AB is that AB is 8 km. So the distance between point A and point B is 8 km. Now let's move our second type of question. Is given that a man go downstream in 4 hours and return upstream to same point in 8 hours. If the speed of still water is 4 km per hour, find the speed of man. First suppose that the man go from point A to point B, which is d distance apart. Now let speed of man in still water is m kilometer per hour. Now according to the question, down speed time taken is 4 hours. So time is equal to 4 hours is equal to distance d divided by speed in downstream, which is m plus 4, because still water speed is 4 km per hour. In the same way, time taken to upstream is equal to 8 hours is equal to d upon m minus 4, equation number 2. Now we have two unknowns and two equations. Now take d equal to 8 multiplied by m minus 4 from equation 2 and put in equation 1. We get that 4 is equal to 8 multiplied by m minus 4 divided by m plus 4, which gives that 4m plus 16 is equal to 8m minus 32. Further solving, we get 4m is equal to 48. M is equal to 12 km per hour. So the speed of man in still water is 12 km per hour. Third type of question is, a man row in still water with speed 6 km per hour to go a certain place and to come back. If the river is flowing with speed 3 km per hour, find the average speed of man. First, let the man is moving from place A to P, which is d distance apart. Now the man let speed of man is m equal to 6 km per hour and speed of stream is 3 km per hour given. So downstream speed is equal to 6 plus 3, which is equal to 9 km per hour, and upstream is equal to 6 minus 3 is equal to 3 km per hour. So according to the question, man go and to come back to the point, man go from A to B and come back from B to A. Find the average speed of mean. So average speed, we know that average speed formula is distance upon total time. We know that total distance is equal to d plus d from A to B and B to A, which is equal to 2d divided by total time. Time taken to downstream is equal to distance upon speed, which is 9 km per hour, plus upstream distance divided by 3 km per hour. Further solving, we get 2d divided by d by 4 plus d by 3, which is equal to 2d multiplied by 12 divided by 7d. On further solving, we get that 12 multiplied by 2 divided by 7. Which is given that 3.59 km per hour. So now we do in this video 3 type of question based on board and stream. In the next video, we will further extend the lecture by doing some more important question based on board and stream. Till then, like, share and subscribe the channel.